Welcome to this short video about the Firebolt Native App SDK, also known as the Bolt SDK. We will show how you can build and sideload Bolt applications. We start with shortly describing what the app developer setup is. As hardware, you need a video accelerator that can be a Raspberry Pi 4, not the 3 and not the 5. It has to be with the RDK 8 image, and you can download such a pre-built from RDK Central. The Raspberry Pi has a mini HDMI output, so you need to have such a cable. You need to have an RCU or a USB keyboard to navigate through the video accelerator menu. And as a PC virtual machine, it needs to be a Linux OS. You need to foresee at least 150 gigabyte free storage only for this, and I would recommend more. For the build environment, you need a Yocto setup with Bolt CLI tools and Ralphpak. You can install these tools directly in your environment yourself, natively, or you can also make use of a ready-made Yocto Bolt Docker builder image with all the tools and dependencies included in there. You can pull this Docker image from here. There is a run script that goes with that, which you can modify to your situation. It's open over here. We mount in your home, we add in your user ID. Make sure you mount in a storage volume and use that to store your build on, so that when you close your container, all your build artifacts are still there in persistent storage. So, okay, let's just run the script and then we'll enter into our container. You will see that here we have all the Bolt tools and we have the Ralphpak tool. You need to one time create a Bolt dir that is used for storing the local Bolt packages in one place. That's the directory, and here you can see a list of bolts beneath it. You also need to create a Yocto state cache and download dir, like in regular Yocto. But here you also need to export them as specific Bolt environment variables. You can do that globally by exporting them in your bashrc. Here's how you can build your first Bolt application. So we are here in the Yocto Bolt builder, the Docker container. First time you build an application, you best start with the simple example app. So you start with cloning the meta layer of that associated application, which is done here, or I already did that, and then you enter into its associated content. I think a good habit is also to create a .env file with the download and state cache dir as environment variables to make sure you hit the caches. The name of the Bolt application is defined in the package config. So for our demo, this is here, Wayland TGL test input. And then, yeah, we load, initialize the Yocto environment. This is typically source setup environment. Here you see the Yocto image direct name. Now we will use the bolt make command with the bolt make with the name of the Bolt application and then with install. So let's do that, and you can use force install if it was already installed. So now this will trigger the Yocto building of the associated image. The first time you do that, you'll have to be quite patient because it can take 1 or 2 hours depending on your machine. Second time you do that, it will go faster. You've seen it just goes less than a minute. Thanks to the cache and the toolchain and the base libs artifacts, they don't need to be rebuilt. So the Bolt package will be installed in the bolts.dir file, which serves as the local Bolt package store. Here it was already installed, that's why you see that error. If you would do force install, you would overwrite it. So now we are ready to sideload it to the Raspberry Pi and run it over there. On the right, you can see the HDMI output of the Raspberry Pi with the RDK 8 image on it, and you can navigate with the arrow keys. On the left, you see the terminal window of the development PC with the Bolt application ready to be sideloaded from the Docker builder. So let's do that. Let's press OK and press the Bolt push command. It's entered into the UI of the Raspberry Pi, so it's here. So let's start it. Let's press enter and let's also enable the logging in that other terminal, which is SSH into the Raspberry Pi. If I press the key down, it should appear in the logging, yeah, which is happening. Let's stop the application with home. So if and let's show another application. The Wanderers app is the Flutter app that I've said, Flutter Native app, which makes use of the Flutter runtime. So let's press enter to start that and show that. Press a bit. It can show nice animations. So press home to stop that. And then here we have a web app, Pixel Dash. If you then would go to the middleware and ask, what applications, Bolt, not application packages are all installed, you will see here a list, WPE, which is now loaded with that web app because that's a runtime beneath the application we started. The ref UI is the main UI that starts it. And then this is the Flutter runtime with the Flutter application, the Cobalt YouTube runtime, the base layer, which is shared across all of them. And this is the web app that's currently playing. That was it. Thank you.